x, okay, you'll basically get 7 over e squared exponential of minus 2x, right? Plus 5 over e squared x e to the minus 2x. And again, if you wanted to, you can simplify it. I didn't care. E to the minus 2x minus 2, right? 5x plus 7. Okay. I think a very straightforward problem, right? Okay. You just solve the homogeneous equation and plug in. Okay. Any questions on that? Hopefully not. Yeah. What?
What are the points for that one? The points for...
The points, okay. 10 for getting the general solution, and then 15 for solving in C1, C2, and going the rest of the way. Okay. Let's go to problem number 2. Find the general solution of this. Okay. And I've said many times that when you have a non-homogeneous equation, okay, constant coefficients, your first try should be, or your first thing that you should look at would be undetermined coefficients. Remember, the method of variation of parameters will always work, but it's much more difficult. So I don't know why people would want to do that, okay? So if you look at this equation, it's constant coefficients, right? And the right-hand side certainly has a finite family, right? The x, the cosine, and the exponential. Okay. So let's do problem number 2. And as we go along, I'll tell you about the points. And it goes without saying that if you did not do, if you lost some points on these or didn't do well, study these solutions because the final exam will be very similar to these type of problems, right?
Actually,
okay.
Quick question on that.
Sure.
For the final, is it, because we're an ME class, is it your own final or is it a district?
I make it up myself.
Okay.
Yeah. Okay. So we got the third order equation, right? Okay. So don't threat, the cubic ain't going to be that bad in this case, okay? Because basically it's r cubed minus 4r equals 0. So first thing is solve the associated homogeneous equation, right? Put the right-hand side equal to 0. Okay, the auxiliary equation or characteristic is r squared minus 4r equals 0, right? Sorry, r cubed minus 4r equals 0. So I can write this as r squared minus 4, or r minus 2r plus 2. It shows these to be real simple as far as the algebra goes. Okay? So now you have 3 distinct roots, right? R equals 0 plus 2 and minus 2. Okay, so I don't need that thing with the x, right? Because they're linearly independent. So the homogeneous solution or the complementary solution therefore would be C1, okay, e to the 0x, which is just 1, right? Plus c sub 2 e to the 2x, plus another constant e to the minus 2x, right? And again, third order differential equation, we need 3 linearly independent solutions to express the general solution of the homogeneous equation. Okay, now we're ready to get the particular solution. Oh, and let me just say for the homogeneous, how much credit did I give? I gave 8 points for this, okay? No, I'm looking at the wrong problem. Sorry, 5. I was about to say. Yeah.
You're about to have a
Everybody's going to come up now. Say, wait. Okay, so 5 for the complementary. Okay. Now I need the family of the right-hand side. Okay? And here's where some people got a little screwed up. And remember what I do again is if you screw up one part, I take your result and I propagate it through so you still can get full credit on the other parts. Okay, let's look at the right-hand side. If you look at the right-hand side, the first term that you get there is an x, right? So what's the family of x? It consists of 2 functions, x and 1. Okay. However, first thing remember I always tell you to do is after you get the family of the right-hand side, or even a part of it, check to see if any of those guys are in the homogeneous solution. And you notice that 1 is there, and that's basically C1 times 1. 1 is the solution of the homogeneous equation, so I have to modify that family to go to x squared x. I think this is where most people lost credit, okay? They didn't, I guess they saw C1 and didn't realize that's really 1, right? Right? Okay. So that goes to x squared x. Okay. And then the family, what's the next guy? 3 cos x, right? Well, that one we know it's sines and cosines. And neither sine nor cosine is a solution of the homogeneous equation, so I don't have to modify that family. And this one most people did modify, okay? What's the family? What's the other term on the right-hand side there, problem number 2? Again, e to the minus 2x. Well, normally that would just consist of one function, e to the minus 2x, right? But e to the minus 2x is obviously a solution of the homogeneous equation, so I have to modify that to be x e to the minus 2x. Okay? And let me just see what I said on the family then. Okay, so you got 5 if you got the complementary. 5 for the family, okay? Another 5 points if you got a family. Okay, of course you got partial credit, you know. Again, most people probably lost credit over here because they didn't modify it. Okay. And then I guess 15 is for the rest, for the particular, because that's always a pain in the neck, right? Okay. So let's get the particular solution. Again, I'm not going to put all the algebra there, okay? Okay, particular solution. I'll come up with it here. Okay, the form of the particular solution has to be what? Okay. Ax squared plus bx for the first family, right? And you know what happened basically, of course, some people got it, some people didn't. When you did x1 and you put, instead of ax squared plus bx, you put ax plus b, you'll find out that the b just goes to 0. And remember I said before, that's an indication, you probably screwed up the family someplace. Okay, ax squared plus bx, right? Plus c sine of x, plus d cosine x, plus another coefficient times the last guy, which is x e to the minus 2x. Okay. I'll just write down the intermediate things, okay? And again, the way to do this so you don't get overwhelmed with the algebra is every time you differentiate, simplify as much as you can, okay? It'll make things easier and also make the subsequent differentiations much easier. So this one there's nothing to do really, it's just 2ax plus b, right? Plus c cosine of x minus d sine x plus e to the minus 2x, so you can factor that out. Then you have a 1 minus 2x. Okay? And yp double prime, again, I'm just going to write the final result. It should be 2a minus c sine x minus d cosine x minus 4 coefficient big E to the minus 2x one minus x. Okay, then we had to go to yp triple prime. Okay? You get a minus c cosine of x plus d sine of x plus 4 cap e to the minus 2x times 3 minus 2x. Okay? And again, see, what I'm interested mostly is you know the method, okay? Okay, I mean, I understand, I'm not going to care too much. You'll use a few points, but the algebra to me is the least important. You do all the stuff, you do the L and YP. As long as I see that you understand what's going on, that's really what's important. Okay? So, when you do L operating on YP, of course you got to do what? You got to do YP third derivative minus 4YP prime. 2 terms, right? And you'll find out when you simplify. Again, how do I know how to simplify? Look at the right-hand side. And clearly I'm going to get sine by itself, cosine by itself, x by itself, and the exponential. So if you do L on YP, you'll find out you'll get a 5d sine x minus 5c cosine of x minus 4b minus 8ax plus 8 big E e to the minus 2x. And that's it. And that has to equal x plus 3 cos x plus e to the minus 2x. Okay? Well, we see on the right-hand side there's no sine x, so therefore big T has to equal to 0. Right? What about c? Well, on the left-hand side, I got a cos x coefficient of negative 5c, got a 3 on the right, so c is minus 3/5. And what about b? There's no constant on the right, so b is equal to 0. And then finally, what about a linear term? Yeah, I got x on the right minus 8ax, so a is minus an eighth. And then finally, the big E, okay, if you compare the coefficients over there, you'll find out that big E has to equal 1/8. Right? So I've got 8E and a 1, okay? So the particular solution, okay, you plug all this stuff back in, you get minus 1/8 x squared minus 3/5 sine x plus 1/8 x e to the minus 2x. And again, you lose a little credit if you don't say y equals yc plus yb. The whole thing. Okay? So again, on problem number 2, you got 5 points for the complementary, 5 for the family, and 15 for getting the particular solution. Okay, any questions on that? Yeah, it's mostly just, algebra, okay? Okay, now we go to problem number 4, the last one, I guess, right? Find the general solution to, this one, I was very surprised, okay? What happens, let me tell you several reasons, okay? Disappointed, it's more of a accurate statement. Problem number 4, okay? One thing, you knew exactly what the topics covered were, okay? You already had one on undetermined coefficients, right? So why doesn't he give me another one? I mean, why would he do that, right? Okay, I look at this one over here, okay, constant coefficients on the left, that's okay, but the right-hand side has an infinite family. As a matter of fact, when I talked about infinite families, I think I gave tangent x as an example, actually, right? So certainly e to the x tangent x has an infinite family. If that wasn't enough, look right below. I tell you the method of variation of parameters, right? So if I was taking this test, I would say, gee, is he just doing this to throw me off? No, I don't do things like that, right? And I really really kind of disappointed in the fact that some people try to do this with undetermined coefficients. Again, for several reasons. The fact that the family is infinite on the right, and then right below I have the method of undetermined the method of variation of parameters, because I didn't want you to have to memorize it. So, I mean, what can I do? It's almost like give me half the answer. Okay, enough of that. Let's just go and see what the solution looks like for that. Okay. Usual thing, we got an inhomogeneous linear differential equation. We know we have to find the solution of the associated homogeneous equation first, right? So that would be y double prime minus 2y prime plus 2y equals 0. Okay, I have r squared minus 2r plus 2 is equal to 0. Okay? You solve that by the quadratic formula, okay? And you'll find that the roots are going to be 1 plus or minus r. Okay? So we know that the complementary solution, y sub c of x, is some arbitrary constant, e to the x sine x, right? plus another arbitrary constant times the second solution, which would be e to the x cosine of x. Okay? And I chose to call this guy y1 and chose to do this guy y2. You could have done it the other way. So I'm setting up the Wronskian writing a particular solution. What will happen now is that your Wronskian and what I'm going to write, if you switch them, would be the negatives of each other. But at the end, everything would be the same. Okay. So now it's just a matter of plugging into the formula over here, right? I even tell you, I had y1 and y2 are the fundamental solutions to the equation. Yeah, here it is, e to the x sine x, e to the x cos x, right? The solution to the inhomogeneous equation is given by that, dot, 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 okay. And this one also, you didn't even have to divide through. The coefficient of y double prime was equal to 1. I could have thrown that in to catch some people, but I decided not to, okay? So, we now have to basically get the Wronskian. That's the first step, right? And again, for people who don't know linear algebra, I even wrote out the Wronskian, right, notes without determinants, okay? But I can never memorize that formula, so I have to do it from scratch. So here you have y1, the first solution, which is e to the x sine x, right? Here you have the second solution, e to the x cosine x, okay? And what do you do in the second row? You differentiate the first row. So I'll give you e to the x, parentheses, sine x plus cos x, okay? And when I differentiate this guy, I'll get e to the x cosine of x minus the sine of x. Okay? And let's just expand out this determinant. I'll get that times that. Well, that picks me up at e to the 2x, right? And then I get sine of x, parentheses, cosine minus sine. Okay? And then minus the other product, which is e to the 2x, cosine of x. This guy sine plus cosine. And remember, I said many times in class that Wronskian is usually very, very simple, right? You factor out an e to the 2x from everything. You multiply out, you use the identity, sine squared plus cos squared equals 1, and you'll find out that in this case, the Wronskian is minus the exponential of 2x. Okay, and of course, it's never equal to 0, and we know that because they're linearly independent. Okay, so there's your Wronskian. Let's just see,